All right, so we have a project for a log home that's gonna have an open concept. The span is over 28 feet. So as you guys know, lumber is very expensive, and to get TJIs or like deep eye joists that will go all the way through, that's a lot of money. So we rather put a column here and a column inside this wall, put a beam, and support our joists in this piece. So the joists are gonna be half of that span. So if it is 28, it's gonna be 14 feet each. So the first thing I like to do is I open my software and I immediately create joists on the floor joist section. And those joists are gonna be 14 feet because we said 28. And I go into my materials and I make sure that I go into solid zones, and we're gonna use the most appropriate one, which probably will be 2 by 12, so 16 inches on center. When you go equal, it's adequate by 51%. You already have it. Beautiful. Now we're gonna size our beam. It's gonna be an uniformly loaded beam right here. You can pick. There is the uniformly loaded. There is the multi-span, and then there is the multi-loaded multi-span. So this is the simplest one right here. And I didn't need to do this joist to do it. It's very straightforward. You go here. You're gonna ask yourself, how long is gonna be my beam? Question number one. How long is my beam going to be? My beam is going to be from this side to this side. It's about 18.5.
19, 2, 3 quarters.
Yeah, I think that dimension is not going there. Well, maybe it is. Maybe
Yeah.
to the center line. Okay. So let's do that. So 19.2. So we're gonna say 19. Let's do 19.5. You always want it to be longer. Why? Because if you can do it for a longer one, you're fine. You can do it for less. So then you have your length. And then the other thing you're gonna tell is the tributary width. The tributary width is gonna be half of this. So if you got this right here, that's 12. So you're gonna be having half of 12 is 6. Actually, my bad. It's right here.
No, it's half of the middle. Yeah.
Half of 14. Okay, so it's gonna be 7. So you're gonna have 7 in one side, and you're gonna have 7 in the other. You've already loaded your beam properly. If there is no walls or anything sitting on it other than that, you're good. Then if you go to equal.
One question.
Hold on one second. I'm gonna answer again. So you go to equal, you're like, oh well, what's going on? Well, you loaded this and put the right dimension. You didn't create the one that you want. What do? I always go to structural composites and I use a rule of thumb. The rule of thumb I use is your beam is gonna have to at least be, if this is feet, whatever that is. Let's say that's X. Whatever that is in feet, you're gonna grab that same number and you're gonna turn it in inches for your depth of your member. Okay? So if this thing is going 19, what is that going to have to at least be to be able to work in a member? It's gonna have to be at least 19.5 inches, right? In inches, right? Great. So, but that's one layer, right? If you do 2 layers, another one that's smaller may be able to do it because you can do one, and then you can do another one, and then you can do another one, and but you can't go infinite because then otherwise there's no column that's gonna be supporting that. There's not gonna be a column like that. Okay. So what are we gonna do? We're gonna go into our structural composite members, and we're going to start with the rule of thumb. It's gonna need to be at least 18 inches deep to begin with. And we're gonna say equal. Doesn't pass because there's only one member. And it's not 19, it's not 20, right? So what if we say 2? Boom, 2 starts passing, but it only passes by 3.9%. You don't want that. You end up with 3. And 3 passes by 54%, and that's correct. That's the member you're gonna do. You're gonna go to your lumber yard and you're gonna buy a 1.8 E2600F. Now, another thing, there's different grades. I use one of the lowest grades, but you could do a higher grade and you could do less member, meaning the quality of the material is better, but it's more expensive, but you have less. I'd rather do 3, and I'd rather do this. All right, and you have to think about a couple things. One, what is my column going to be? Because you cannot have a beam that's substantially bigger than the little column that you're going to be supporting. Because then that's not transferring properly, right? So you think of these three layers are 1 3/4, so 1.75 plus 1.75 or 1.75. What does that give you? Right, that's already giving you about 3 1/4, and then it's 4 1/2. So that's a regular 2x6 wall. So you could literally put 3 studs right here together, and you could probably support them. Okay, that's really straightforward, very quick. Now, questions for you. Anyone has any questions? Now is the moment to ask them.
My question was the live load. Like if you're sizing that beam, would you add the live load for the second floor, or that doesn't matter if you're only sizing the first floor?
No. I wasn't sizing the first floor. What are you talking about? I was sizing the second floor. I was sizing the load that are gonna sitting on this on the second floor.
Yeah, but I'm saying, let's say this is a three
There
level.
is, I'm using this plan to show you that there is something like this going on the second floor. That's what I'm doing right now. It's my second floor. I'm just using this plan as an example to show it. But it's my second floor. And it already on the software is calculating the live and dead load for my second floor. Where is that? I'll show it to you right now. Let's struggle. So floor live load, 40 pounds per square foot. Floor dead load, 15 pounds per square foot. That's already all factored in. If this was a roof, the first thing is you could change it to be a floor beam or a deck beam, meaning the deck will have snow loads too. And you can check the snow loads and you can add them. But that's that. Any other question? Is that clear?
Yeah.
Any other questions?
40 and 15 is you know, put nothing here.
This is given to you by the building code.
Oh yeah.
The building code that you're using, whichever, well, I don't see it here, but it is now it's using the 2015. If anything changes, you can just plug them in. You just have to keep in mind that right now this is using the 2015 International Building Code
Oh
and the 14th edition of the steel
yeah.
and 2015 of the National Design Specification.
Yeah.
So all of this is to those codes, okay?
That is my question.
Now there's a bunch of other codes here, but yeah.
This is the same the NLCAP?
I'm sorry, no, this is not in NCAR. This is a software called structural calculations. What do you mean?
Is the other program is the same APP to the structure NLCAP? Is the you put in the information to the code and
Yeah.
calculate or all the thing? Yeah.
Yeah, this is using the International Building Code already as a reference.
Okay.
Yeah, like by itself, they already has it. You can pick the one that is the one that you're using. In this case, we're using this one because that's what we use in Massachusetts as of right now. It is going to 2021.
22.
Yeah. So but yeah, so that's gonna be changing. But what I do is I go to the pages and change my floor, live load, and dead load. If it changed, likely it didn't change. It's worked.
Pero en here in New York now is the 22.
Yeah, 22. Yeah, but but I just update this. I'm
behind.
using this one as a reference, and that's what I use. So I hope this was helpful. I know this was quick. Subscribe, like, and share. Thank you.